Students, today we will discuss special cases in the simplex method. So basically we are having four cases which we have already discussed in graphical method. One is the degeneracy, second one is the alternate optima, third one is the unbounded solution, and the fourth one is non-existing or infeasible solutions. So today we will discuss only these three: first, second and third: degeneracy, alternate optima and unbounded solutions. We will discuss the fourth one after discussing BigM and two-phase method. Okay. First, what is degeneracy? We have already discussed this degeneracy in the graphical method. Degeneracy means we are having a redundant constraint. For example, in this example you can see this is redundant. If you remove this, still you are getting the optimum solution at this point. We have already discussed this example. So this is the area, shaded area is the optimum solution obtained at this point. But if you remove this constraint, then still you are getting the same solution. That means this is just like a redundant or parallel constraint. Okay, just remove this, then still you are getting this. So this is called degeneracy. But how we can detect the degeneracy in simplex table without knowing the graph? This is the problem. Okay, because if our problem is more than 2 dimension, then this is very difficult to construct the graph, and in that case we are unable to find out the degeneracy. This is our problem. So let's see. In the application of the feasible condition of the simplex method, a tie for the minimum ratio may occur, and a tie between minimum ratio, because we have seen that whenever we are finding the minimum ratio, for example here, whenever we are finding the minimum ratio, so we will find out a value. But sometimes what happens, we are having a common. For example, here you can see the minimum ratio 8/4, 4/2, that means 2 and 2. So there is a tie between these two, because both are at the same level, 2 and 2. That's why whenever we are having a tie or we are having same value for more than 2 ratios, then in that case we are having the case of degeneracy. So in the application of the feasibility condition of the simplex method, a tie for the minimum ratio may occur and can be broken arbitrarily. When this happens, at least one basic variable will be 0 in the next iteration. Let's see what is the meaning of that. But you can see that, for example, here we are having tie 2 and 2, both are same level. So suppose we have selected arbitrarily, say this one. Either we can select, because -9 is the most negative one, so x2 enters the basis. Then we will select find out the minimum ratio, and you can see that 8/4 and 4/2 both will provide you 2 and 2. Hence we can either select x3 as the leaving variable or x4 as the leaving variable. So suppose we have randomly selected, say, x3 will leave the basis. So when you divide this first row by 4, then you are getting 2 1/4, 1 1/4 and 0. When you are trying to convert this 2 as 0 with the help of this one, then you will see that we will have 2 minus 2, and hence we are getting 0 here. Okay, so this is the meaning, that when this happens, at least one basic variable will be 0 in the next iteration. That means this concept, this zero is the meaning of this. Okay, and the next new solution is said to be degenerate. So whenever in the value column you have a 0, due to this calculation process due to the presence of this minimum ratio, this process is called degenerate. Okay, so degeneracy can cause the simplex iterations to cycle indefinitely. Sometimes what happens, due to this we are getting same solution. Once you are getting this solution, in the next iteration we will repeat the first one, and so there will be a cycle. Actually there will be a cycle, we are moving same iteration number of times. So this is and this process goes and goes on and on. Okay, sometimes this is not particularly in any situation, but sometimes. So degeneracy can cause the simplex iteration to cycle indefinitely and thus never terminating the algorithm. The condition also reveals that the model has at least one redundant constraint. Okay, so let's see the example. So suppose we have this problem: maximum z is equal to 3x1 plus 9x2, subjected to x1 plus 4x2 is less than equal to 8, x1 plus 2x2 is less than equal to 4, and x1 x2 is greater than equal to 0. Then now add slack a variable here and here, so we get x1 plus 4x2 plus x3 is equal to 8, x1 plus 2x2 plus x4 is equal to 4. We can use s1 here, we can use s2 here. Okay, so either you can use x3 x4 or s1 s2 s3, and also both are same, there is no difference. So here x1 x2 x3 x4 all are greater than equal to 0, where x3 and x4 are the slack variables. Fine. So now first convert the table, first write down the table. So table is, first row, coefficient of x1 is 1, coefficient of x2 is 4, coefficient of x3 is 1, and there is no x4 in the first constraint, so 0, and the right hand side is 8. Okay, so this is value column. Similarly, second constraint, coefficient of x1 is 1, coefficient of x2 is 2, coefficient of x3 is 0, and coefficient of x4 is 1, and right hand side is 4. Now write down the objective function. This can be written as, say, z minus 3x1 minus 9x2 is equals to 0. So coefficient of x1 is minus 3, so minus 3. Coefficient of x2 is minus 9, so minus 9. There is no x3 and x4, so 0, 0. And right hand side is 0. Now the variables are concerned. Here the identity matrix is, you can see that corresponding to x3 and x4. Hence here is a 1 for the first column of the identity matrix which is associated with x3, so x3. Here is 1 which is associated with x4, so x4, and here is the z, this part z. So this is the initial iteration. Now in this row, z row, the most negative is minus 9, hence we can say that this x2 enters the basis. And now find out the minimum ratio for positive values. So both are positive, so the minimum ratio is 8 by 4 and 4 by 2. So this is x2 enters the basis and minimum ratio is 8 by 4, 4 by 2. So both gives you, both will provide you 2 and 2, hence a tie, and you can select 2. And suppose we have selected x3 as the leaving variable, so we are selected x3. You may also select x4. Suppose you are not interested in x3, you may take x4, no, because the ratio is same. Okay, so suppose we have selected here x3, and hence we can say that x4 is the pivot element. Now then do your usual calculation. First convert this element 4 as 1 with the help of row operations, and then this 2 and minus 9 as 0, 0. So first row is divided by 4, so that you will have a 1 here. So just divide this first row by 4, and before that, what are the new bases? Here we have x2 and x4, because x2 enters the basis, x3 leave the basis. So x3, in place of x3 we have x2 and x4. This is our z. Now divide first row by 4, so we get 2, 1 by 4, 1, 1 by 4, 0, and then convert this 2 and minus 9 as 0, 0 with the help of this 1. So here is 2, here is 1. So just multiply this row by 2. Just multiply this row by 2 and then subtract from first row. So we have 0, 1 by 2, 0, minus half and 1. इस इक्वेशन को 2 से मल्टीप्लाई किया और इस इक्वेशन से और इस रो से सब्ट्रैक्ट किया. Fine. So we get this. Similarly, multiply this first row by 9. 9 से multiply किया and then add in z row and write down here. So we get 18 minus 3 by 4, 0, 9 by 4 and 0. Now identify any negative element in z row. Yes, there is a negative value. Hence we can see that this is the only value. If there are more than one value, so then we have to select the most negative one. But since this is the only single one, hence x1 enters the basis. So x1 enters the basis. Now find out the leaving variable for which we have to find out the minimum ratio, and minimum ratio is associated with positive values, and both are positive, hence the minimum ratio is 2 divided 1 by 4 and 0 divided by half. So 2 by 1 by 4 and 0, so minimum is 0, which is associated with this, and hence we can say that x4 will leave the basis. So now x4 will leave the basis and x1 will enter the basis, so the new basis will be x2 and x1. Okay, now we have to convert this pivot element as 1, and then 1 by 4 and minus 3 by they should be 0 0. So to convert this element as 1, just multiply this row by 2. So 2 से multiply किया, so we get 0 1 0 minus 1 and 2. Now multiply this row by 1 by 4. 1 by 4 से multiply करेंगे and then subtract from the first row. So what we will get? We get 0 2 0 1 half and minus half. At the same time, just here is minus 3 by 4. So just multiply this second row by 3 by 4. 3 by 4 से multiply करेंगे and then add in this z row and write down the resultant in this row. So we get 18 0 0 3 by 2 and 3 by 2. Fine. Now identify any negative element in z row, and there is no negative element, hence optima reaches, and the solution is x2 is 2 and x1 is 0. That means this point is the solution, and this 0 in the value column, this 0 represents that solution is degenerate. So whenever in the value column we have a 0, then 0 represents degeneracy. Fine. Okay, so this is the degeneracy case. Now the next, alternate optima. So alternate optima, so an LPP may have an infinite number of alternative optima when the objective function is parallel to a non-redundant binding constraint. We know what is binding and what is non-binding. Binding means the constraint which exactly satisfy the solution which exactly satisfy the constraint is known as binding, otherwise non-binding. Okay, so an LPP may have infinite number of alternate optima. एक से ज़्यादा optima हो सकते हैं when the objective function is parallel to a non-redundant binding constraint. हमने देखा है कि when our objective function is basically parallel to the constraint, then sometimes we are having more than one solution. In the graphical method we have already seen this. Okay, so that is a constraint that is satisfied as an equation at the optimum solution. The existence of alternative solution can be detected in the optimal table by examining the z equation coefficients of the non-basic variable. That means we identify this z row for the non-basic. That means non-basic means those are not listed herein. For example, in the first iteration there is no x1 and x2 here, so x1 and x2 are non-basic variables. So identify the entries for the non-basic variables, that means corresponding to x1, corresponding to x2. This is the meaning. Okay, so the zero coefficient of non-basic variable indicates that there is an alternate optima exists. That means if for the non-basic one, for example in this iteration x1 and x2 both are non-basic, and there are minus 2 and minus 4, but if suppose corresponding to x1 we are having a 0 here, then we can say that we are having alternate optima. Okay, अगर non-basic के corresponding यहाँ 0 आ जाता है, then we can say that we are having alternate optima. ठीक, this is the meaning. So alternate optima can be found by entering corresponding non-basic variable and by leaving suitable basic variable having minimum ratio. यानी अगर हमें दूसरा solution निकालना है, alternate निकालना है, तो अगर 0 यहाँ आ जाता है, so we can enter that element, उस variable को आप enter कर सकते हैं. Okay, because 0 may have positive as well as negative sign. Fine, this is the reason we can enter and then find out the alternate optima. Let's see the example. This is the example. Maximum z is equal to 2x1 plus 4x2 subjected to x1 plus 2x2 is less than equal to 5. x1 plus x2 is less than equal to 4. x1 x2 is greater than equal to 0. So or this can be rewritten as objective function z minus 2x1 minus 4x2 is equals to 0. Okay, now write down this. So add slack variable here x3, add here slack variable x4. So we get x1 plus 2x2 plus x3 is equal to 5, x1 plus x2 plus x4 is equal to 5, where x3 and x4 are basically the slack variables. Now write down the first constraint. So coefficient of x1 is 1, coefficient of x2 is 2, coefficient of x3 is 1, there is no x4 so 0, right hand side is 5 so 5. Similarly the second constraint, coefficient of x1 is 1, coefficient of x2 is 1, coefficient of x3 will be 0, x4 1, right hand side is 4. Now the objective function, coefficient of x1 is minus 2, coefficient of x2 is minus 4, there is no x3 x4 so 0 0, and this z is written here. Now identify the identity matrix here. So we get 1 0 0 1. So 1 0 first column is associated with x3 so x3. Second column is associated, this 1 is associated with x4 so x4. So this is the initial table. Now identify the most negative value in the z row. So this is the most negative value minus 4. Hence we can say that x2 enters the basis. So x2 enters the basis. Now find the leaving variable with the help of minimum ratio for the positive values. Both are positive. So the minimum ratio will be 5 divided by 2 and 4 divided by 1. So 5 divided 2, 4 divided by 1. So 5 divided 2 is the minimum one. So that's why this 2 is the pivot element, and hence we can say that x3 will leave the basis. So x3 will leave the basis. Now divide the first row. Now what is our next aim? Convert this element as 1. So just divide this row by 2. So we get, so the new basis will be x2 and x4. Okay, because x3 leaves and x2 enters. So x2 x4, x3 निकल गया, x2 enter हो गया है, तो x2 x4. Now divide this row by 2. So 5 by 2, 1 by 2, 1, 1 by 2 and 0. Then with the help of this 1, convert this element as 0 and this element as 0. तो इसको 0 बनाने के लिए क्या कर सकते हैं हम? We can subtract this second row from by first. यानी we can subtract the second row. Okay. So now subtract 4 minus 5 by 2, so 3 by 2, 1 minus half, half, 1 minus 1, 0, 0 minus half, 1 minus 0, 1. Similarly, यहाँ 0 बनाना है, so just multiply the first row by 4. 4 से multiply करो and then add in this. So 4 से multiply करेंगे इसको तो कितना हो जाएगा 10, so 10. इसको 4 से मल्टीप्लाई करेंगे तो 2, 2 माइनस 2 विल बी 0. इसको 4 से मल्टीप्लाई करेंगे, इसमें ऐड करेंगे तो 0. 2 4 से मल्टीप्लाई करेंगे तो दिस विल बी 2, 2 प्लस 0 2. इसको 4 से मल्टीप्लाई करेंगे एंड ऐड इन हियर तो 0. सो नाउ आइडेंटिफाई द जेड रो. Identifies that there is no negative value. Okay, but you can see that here x1 is a non-basic variable because this x1 is not listed here, but there is a 0. There is a 0 associated with this non-basic variable. So this indicates that this 0 indicates that so optima reaches 0 in x1 column. Z row indicates this 0 in Z row indicates that there is an alternate optima. So alternate optima can be found by entering x1 and leaving variable as x4. So if you want to, this is also optimum solution. Optimum solution is x2 is 5 by 2 and x1 is 0 because we have a two-dimensional problem. So x2 is 5 by 2 and since x1 is not listed here, so that's why its value will be 0. So x1 is 0 and x2 is 5 by 2. But if you want to find out alternate solution, because 0 is here, then you can enter this variable. So x1 enters the basis. Now find out the leaving variable with the help of minimum ratio. So minimum ratio will be 5 by 2 divided by 1 by 2 and 3 by 2 divided by 1 by 2. So that's why minimum ratio occurs for x4 and hence x4 leave the basis. So x4 leave the basis and hence the alternate solution will be in place of x4 here we can add x1 here. So x2 and x1. Then now convert this element as 1. इसको 1 बनाने के लिए क्या कर सकते हैं? Just multiply this row by 2. So we get 3, 1, 0, minus 1 and 2. Then यहाँ हमें 0 बनाना है तो क्या कर सकते हैं हम, डायरेक्टली आप इससे इसको सब्ट्रैक्ट करा दो, ये भी हाफ है, ये भी हाफ है, जस्ट सब्ट्रैक्ट. सो when you subtract 5 by 2 minus 3 by 2, we get 1. Half minus half, 0. 1 minus 0, 1. Half minus minus half will be 1. And 0 minus 1 will be minus 1. Okay? And here already 0. So as it is same. And hence we can have alternate optima. Okay? So this is the meaning. Now again you can see that this is a non-basic variable because x1 is and 0 is here. So when you again enter this, again you are getting the same solution this. So that's why we are having two solutions. When you join these two solutions, the entire line segment joining these two solutions represents infinitely many solutions. According to the graph, you can see this is the constraint, this is another constraint. So this constraint is basically the first constraint, number 1. This is our second constraint. When you draw the common area, so this is the common area. And optimal solution here, what is the solution? X1 is 0 and x2 is 5 by 2. So this is the solution, x1 is 0 and 5 by 2. That means point B is the solution. Now the here x1 is 3, x2 is 1, that means point C. So when you join these two, the entire line segment BC is basically the solution. BC is the solution. Okay? Now the third one. Third is the unbounded solution. Third is the unbounded solution. So in some LPP, the solution space is unbounded in at least one variable, meaning that variables may be increased indefinitely without violating any of the constraint. यानी कि हम सॉल्यूशन को कितना भी बढ़ा सकते हैं. फॉर एग्जाम्पल इन केस ऑफ मैक्सिमाइजेशन हम बढ़ा रहे जा रहे हैं, बढ़ाते ही जा रहे हैं अपने सॉल्यूशन को, तो बढ़ता ही चला जाएगा. दैट इज बेसिकली द अनबाउंडेड. ओके, सो द associated objective value may also be unbounded in this case. So an unbounded solution space usually is a sign that the model is poorly constructed. So in simplex table में हमें कैसे पता लगेगा कि unbounded है? So in simplex table, if at any stage corresponding to any of the non-basic variable column, all the entries including z row elements are non-positive हो, that means less than equal to 0 है, then solution space is unbounded. यानी कि किसी भी नॉन बेसिक वेरिएबल कॉलम में, फॉर एग्जाम्पल यहाँ आप देख सकते हो x2 इज नॉट लिस्टेड हियर, दैट मीन्स x2 इज नॉन बेसिक वेरिएबल. नॉन बेसिक है क्योंकि ये लिस्टेड नहीं है यहाँ, और सारी एंट्री आप देख सकते हैं इस कॉलम में या तो निगेटिव है या 0 है, -1 0 -1. दैट्स वाई दिस इज अ साइन ऑफ अनबाउंडेड सॉल्यूशन. whenever you are having less than equal to 0 entries corresponding to a non-basic variable, then that represents basically unbounded solution. So this is the example. Maximum z is 2x1 plus x2 subjected to x1 minus x2 less than equal to 10. 2x1 is less than equal to 40. x1 x2 is greater than equal to 0. So the problem can be written as z minus 2x1 minus x2 is equal to 0. Now add slack variable here, x3. So x1 minus x2 plus x3 is equal to 10. Add slack variable another x. So suppose x4. So 2x1 plus x4 is equal to 40. So x1 x2 x3 x4 is greater than equal to 0. Okay, then this is the initial table. First constraint is 1. So coefficient of, so write down here basic variable value column, then all the variables x1 x2 x3 x4. Now write down the first constraint. Coefficient of x1 is 1, so 1. Coefficient of x2 is -1, so -1. Coefficient of x3 is 1, so 1. There is no x4, so 0. Right hand side value is 10. Now the second constraint, coefficient of x1 is 2, so 2. Coefficient of x2 will be 0. Coefficient of x3 will be 0. And x4 will be here, coefficient will be 1. Right hand side is 40, so 40. Okay. Now write down the z objective function. So coefficient of x1 will be -2. Coefficient of x2 will be -1. There is no x3 x4, so 0 0. And right hand side is 0. Now identify the identity matrix here in this part. So we get 1 0 0 1. So 1 0 is associated with x3, this one, so x3. 0 1 is associated with x4, so x4. Okay, this 1 is associated with x4, so x4 here, and this z is from here, this is z. Now identify here This x2 is a non-basic variable because not listed here, and all the entries are either negative or 0, and hence we can say that this is an unbounded solution. Now if you look at the graph of this problem, so this is the graph. This is basically our second constraint, this line, and this first constraint is basically this, and non-negativity condition shows that we are having in positive axis. So ultimately the shaded is part is basically the feasible region. Now you can see that there is no upper bound here, this is open here. You can improve xt, आप x2 को जितना बढ़ाते रहें, क्योंकि x1 तो बाउंड है, x1 पे तो बाउंड है हियर, बट देयर इज नो लिमिट ऑन x2. x2 को आप बढ़ाते रहें, एंड वेन एवर यू आर x2 इन इंक्रीजेज, मैक्सिमम z इंक्रीजेज बिकॉज हियर इज अ पॉजिटिव साइन. तो x2 को आप बढ़ाते रहें, ये बढ़ता रहेगा, हैंस अनबाउंडेड सॉल्यूशन. दैट्स व्हाई सॉल्यूशन इज अनबाउंडेड. ओके, सो दिस इज unbounded solution. So now so we have discussed three basically special cases: degeneracy, alternate optima, and unbounded solution. We will discuss the fourth one, infeasible one, this infeasible solution after Bingham and two-phase methods. Okay, so before that, going to start the fourth one, we have to discuss what is basically the artificial variable. What is the meaning of artificial variable? So to understand the artificial variable, let's see. Suppose we have this problem: minimum z is equal to 2x1 plus x2, subjected to 3x1 plus x2 is equal to 3, 4x1 plus 3x2 is greater than equal to 6, x1 plus 2x2 is less than equal to 3, and x1 x2 is greater than equal to 0. Okay, so now if you basically use your ordinary simplex method, then what is basically the problem? So to understand the problem, let's see, we have this. So first add the slack and surplus variable. So we have minimum z is equal to 2x1 plus x2, subjected to 3x1 plus x2 is equal to 3, 4x1 plus 3x2 is greater than equals to 6, and x1 plus 2x2 is less than equal to 3. This is our problem. Okay, so now what we will do, just forget this, just consider this problem. Now use your existing concepts, just add slack and surplus variable. So minimum is converted as maximum one, so maximum z star is equal to say minus z, minus से multiply करा देंगे, so we get minus 2x1 minus x2, subjected to, इसको क्या करेंगे as it is, because this is equality, so 3x1 plus x2 is equal to 3. There is no need, suppose we are not doing anything, we are just converting all these in equality form. So this is already equality, so there is no need to add any variable. Now here 4x1 plus 3x2 minus say x3 is equal to 6, where x3 is the surplus variable because we have subtracted some amount x3, then we are getting equality. Okay, now here just add some amount, x1 plus 2x2 plus say x4 is equal to 3. So x1, x2, x3, x4 all are greater than equal to 0, where x3 is surplus, x3 is slack. Okay, this is the existing, जो भी हमें पता है वो ये पता है अभी तक. Okay, let's see, construct the initial table. So basis, value, then x1, x2, x3, x4. Okay, now the first constraint is this: coefficient of x1 is 3, coefficient of x2 is 1, there is no x3, there is no x4. Fine, right hand side is 3. Now second constraint, coefficient of x1 is 4. Okay, coefficient of x3 is 3, coefficient of x3 is minus 1, and then there is no x4, so 0. Here we have 6. Now third one, coefficient of x1 is 1, coefficient of x2 is 2, there is no x3, coefficient of x4 is 1, and then right hand side is 3. Now write down the objective function. This is basically further rewritten as here I am writing this z star, इसको हम इधर लेके जाएंगे, so this will be plus 2x1 plus x2 will be 0. So here we are writing z star, this z star right hand side is 0, coefficient of x1 is 2, coefficient of x2 is 1, and 0 and 0. Okay, now identify the identity matrix so that you have a basis. So identity, we have only one column 0 0 1, so that's why we have only one here, so x4 we can write down here. But what about these two places? Because we are not having the first two column of the identity matrix, this is the problem. So if whenever we are facing this type of problem, then we just artificially add the required columns. So since we are having only third column, we don't have any first and second column, so suppose we are adding here 1 0 0 and 0 here artificially, second column will be 0 1 0 0. Okay, and since we have added artificially, हमने सिर्फ इसको artificially, that means imagination, this is our imagination that we are adding two columns, where we are having two columns, but actually they are not there. हमने सिर्फ ये हमारा एक imagination है कि yes we are having two columns, that's why the corresponding variables, those are known as artificial variables, they are not exist. But to start the solution process of simplex method, we have to add these columns, otherwise we are unable to apply the method. Okay, so suppose we have added 1 0 0, and since we are designate them as artificial variable, that's why we call it as say a1, first artificial variable, that's why a means artificial variable, first one, so a1, second column is suppose a2, so this is our column a1 and a2. So where a1 and a2 are artificial variable. Now you can see we have added here 1, so we can write down a1 here, here 1 which is associated with this, so a2. So now our procedure is complete, and now we can apply our ordinary approach. But since we have added a1 and a2 artificially, that's why we have to basically we have to apply some changes in our existing simplex method. तो हमें अपने एग्जिस्टिंग अप्रोच में थोड़ा सा चेंज करना पड़ेगा, बिकॉज वी हैव एडिड आर्टिफिशियल वेरिएबल्स, एंड दोज चेंजेस आर बेसिकली नोन एज बिगम मेथड एंड टू फेज मेथड. दो तरह से हम चेंज कर सकते हैं, वन इज बिगम मेथड, अनदर वन इज टू फेज. दे आर बेसिकली द मॉडिफाइड वर्जन ऑफ सिंप्लेक्स मेथड. ओके, सो अब आप देखेंगे यहाँ हमने a1 ऐड किया है, फर्स्ट कंस्ट्रेंट में हमने यहाँ 1 ऐड किया है. That's why in the first constraint here we have to add another variable here plus a1. a1 is equal to 3. So equality थी, but still we have to add one artificial variable here, so that जब इसकी एंट्री करेंगे आप, coefficient of x1 is 3, coefficient of x2 is 1, x3 x4 0 0, and a1 will be 1, and right hand side is 3. Okay, similarly in the second column here we have added 1 which is associated with the second row, so यहाँ भी हमें ऐड करना पड़ेगा plus a2 is equals to 6, and then we have this 1 here. So whenever basically generally practice क्या है, whenever we have equality we have to add one artificial variable, whenever we are having greater than sign equal to, then subtract this surplus variable, and then immediately you have to add another artificial variable, so that you have identity matrix. Okay, तो जब भी हम slack surplus variable का इस्तेमाल करेंगे, generally we have to add an artificial variable. जब भी हमें equality मिलेगी, immediately we have to add an artificial variable. Okay, but sometimes क्या होता है कि हम already प्रॉब्लम ऐसी बनती है कि हमें आर्टिफिशियल वेरिएबल इक्वालिटी होने के बावजूद भी हमें ज़रूरत नहीं पड़ती. आप देखेंगे ऐसे एग्जाम्पल, क्योंकि उसमें आइडेंटिटी मैट्रिक्स ऑलरेडी बन जाता है. ओके, फॉर एग्जाम्पल ये अगर ये 3 वेरिएबल की प्रॉब्लम होती x1 x2 x3 और यहाँ पर ये x2 की जगह x3 होता तो x3 कॉलम में 1 0 0 एक कॉलम ऑलरेडी बन जाता हमारा, तो हमें ज़रूरत ही नहीं पड़ती एक आर्टिफिशियल वेरिएबल ऐड करने की a1, हमें सिर्फ यहाँ ऐड करना पड़ता। ओके, सो दिस इज द मीनिंग। तो हमें देखना पड़ेगा कि आइडेंटिटी मैट्रिक्स बन रहा है कि नहीं बन रहा। अगर नहीं बन रहा है तो जितने कॉलम की जरूरत है उतने आर्टिफिशियल वेरिएबल हम ऐड कर लेंगे। ओके तो इन द नेक्स्ट वीडियो वी विल डिस्कस अबाउट द बिगेम एंड टू फेज मेथड्स। ओके, सो थैंक यू।